So in this video we are going to see the minimum diameter in the punching or piercing operation. The minimum diameter in punching or piercing. Okay, so let us see. This is our punch, and this is the sheet. This is the die. Okay. Now, when the force is applied by the punch, this force is F max in the sheet metal operation. So definitely, if you look at the bottom of the punch, of course the punch is cylindrical one, and bottom is what? It's circle. It's a circular, isn't it? So definitely, when the punch is applying the force on this sheet material, so this sheet material also is going to have the equal and opposite reaction onto the bottom of the punch. See here, this is the bottom of the punch. Of course, on this, the sheet is also going to have the equal and opposite amount of force, isn't it? Equal and opposite. Okay, so now you know that the force is applied by the punch on the sheet, that is our F max, is equal to what? The pi dt into shear strength of the material, isn't it? And if we have the sigma c as a compressive strength, of the punch material, now this is equal to what? The sigma c, that is allowable compressive strength or allowable compressive stress, which is going to act at this bottom of the punch. Okay, so how it can be calculated? That sigma c, allowable compressive strength, will be the cross section area of the circle, that is pi by 4 times d square. And what is sigma c? That is going to act as a F max. So equal and opposite F max. For that F max, it will give the reaction from or at the bottom portion of the punch, as the sigma c is equal to this force divided by area. This is the allowable compressive strength of the punch material. And what is the thing? These two are same. Okay, equal and opposite direction. So okay, so here we are having this sigma c is equal to F max divided pi by 4 d square. Now you know what is our F max, how much force is going to act here? That is pi times d times t into tau s divided by pi by 4 d square, isn't it? So here see, this pi get cancels, this d get cancels here. So what we get? The 4 times sigma c into d is equal to t times tau s, isn't it? So what we want actually, what is the minimum diameter that can be punched in this operation, as this is our d minimum. So what is d minimum? So it is not 4 will be go at the numerator here, this is 4 will be here. So what we can write? So this sigma c is equal to force times thickness into shear strength of the material. Okay, where sigma c is the allowable compressive strength of the punch material, tau s is the shear strength of the sheet material, and t is what? The thickness of the sheet. T is what? The thickness of the sheet. So you get the value for diameter here, so it is multiplied by d, the diameter. So d will be what? The 4 times thickness into shear strength of the material divided by allowable compressive strength for the punch material, which is your d minimum. Okay, so let us say that if the tau s equal to sigma c, this tau s is equal to sigma c, then what can you write from this equation? D minimum is equal to 4 times thickness of the sheet. 4 times thickness of the sheet. Please remember this. Now if in the question, if they have provided the factor of safety, then on which material you will take the factor of safety? Of course, on the punch material you will provide the factor of safety. Okay, on the punch material. If in the question the factor of safety is given, then you have to use it on the punch. Okay, that the punch you are going to safeguard, isn't it? So let us say, for example, you are given with the factor of safety 3 and the allowable compressive or crushing strength of the punch material is say 1500. So what you will do? So your sigma c will be here what? 1500 divided by factor of safety, that is 3. Yes, so 1500 divided by 3, that is the 500 will be your allowable crushing strength or compressive strength of the punch material. So from this it is now clear that this minimum diameter which can be punched in the punching or piercing operation is how much? 4 times thickness into shear strength of the sheet material divided by allowable compressive strength of the punch material. Okay, so this is a very important formula. And what to do when FO is given? It is taken on the punch material. Okay, we will see the numericals on this in the gate questions. Okay, thank you.